NestJS is a powerful backend framework, and MongoDB is an extremely flexible and scalable database. Together, they form an amazing combination that I use all the time. In this video, I'll show you how to connect a NestJS application to a MongoDB database, and I'll demonstrate how to query, insert, and edit data. But here is what some developers don't realize. There are several ways to connect a NestJS application to a MongoDB database, and in this video, I'll walk you through the three most popular methods: Mongoose, TypeORM, and the often underrated MongoDB Node.js driver method. But why would you choose MongoDB in the first place? MongoDB can handle a huge amount of data, and it's very good at distributing data across multiple servers. It's schemaless, which means that you can store data without having to define a schema first, which makes it very flexible. So let's kick things off with the most direct approach. The MongoDB Node.js driver method is the absolute simplest way to connect your app to Mongo. To implement this option, you first install the MongoDB Node.js driver, and for the 3 demonstration, I'll start with the same base application. And I was a little bit hungry when I started working on this video, so we will be using a food recipe module, and our goal is to connect the recipes service to a MongoDB database. After you've installed the MongoDB dependency, you can create a MongoDB module in your NestJS app. And in that module, you can declare a MongoDB client and create a provider that connects to a MongoDB server and provides an instance of the database you want to work with. Now you can import the MongoDB module inside the recipe module. And after that, you inject the database into the recipe service, and you can use it to find, create, update, and delete recipes. This method comes with some significant advantages. For starters, it's incredibly simple. There is no need to learn any complex tools like an ORM or an ODM. You're working directly with the database, which gives you complete control over your queries and operations. While the MongoDB driver method offers simplicity and speed, it has some potential drawbacks. So one of the main challenges you might face is the need for manual data validation. So unlike other methods we'll discuss later, the Node.js driver doesn't validate your input data, and this means that you'll need to implement your own validation logic to ensure data integrity. But if you are someone who appreciates having complete control over your database interactions, if you're comfortable with the MongoDB's query language, then this is the ideal option for you. But if you need more structure and built-in features, that's where our next option comes in. So we'll be exploring a tool that can make your MongoDB interactions feel almost magical, providing robust data modeling and built-in validation out of the box. Mongoose is an extremely popular library for MongoDB, and the vast majority of examples you'll find online will use it. So Mongoose is a library specifically created to simplify data modeling and validation through schemas. So let me show you how you can set it up and use it in your NestJS application. First, you need to install Mongoose and the Nest module for Mongoose. Then you can add the Mongoose module to your app module and pass the MongoDB connection string in order to connect to your database. Now, here is where Mongoose starts to show its magic. So Mongoose uses schemas to define the structure of document within a MongoDB collection. And with NestJS, you can use decorators to make this process even smoother. We already have a recipe class, but in order to convert it into a Mongoose schema, you need to decorate it with the schema decorator and the properties with the prop decorator. We don't need to decorate the ID property because by default, Mongoose already uses that field regardless of its presence in the class. Then you can import a scoped module for the recipe entity in the recipe module. And finally, you can inject the model into your service and use it to interact with the database. You use the method provided by the model to find recipes, update, create, and delete your recipes. As you can see, Mongoose provides a very convenient way of defining your data structure and interacting with your data. But Mongoose isn't just about defining data structures. It also provides powerful features for working with your data. So you have built-in validation to ensure that only data matching your schema makes it into the database. And you have middleware support to allow you to hook into the document lifecycle, performing operations before or after certain actions. This kind of data manipulation would require much more manual work with the MongoDB Node.js driver option. Once you've learned it, Mongoose does make certain tasks easier, but of course it means that you are adding another layer of abstraction to your application, and in a way, defining a schema kind of reduces the benefit of having a schema-less database like MongoDB, because this can be a limitation, especially if you are starting a new project and you are not sure about the final structure of your data. But for many developers, the benefit completely outweigh the potential drawbacks. If Mongoose is like a specialized tool for MongoDB, think of TypeORM as the Swiss Army knife of database integration. TypeORM is a mature object relational mapper that allows developers to connect to both SQL and NoSQL databases, including MongoDB. To get started with TypeORM, you need to install TypeORM and the Nest module for TypeORM. The first thing to do is to add the TypeORM module to your app module. You'll need to set the type to MongoDB and provide the connection URL in the URL field. The synchronize option is set to true so that we don't have to worry about migrations for now, but in a production environment, you should not use this option. The entities field is where you register all the classes that represent your MongoDB collections. Just like in the previous example, we have our recipe class, but this time we'll use the entity decorator to define the class as a database entity, and we'll use the column for the properties. TypeORM has a dedicated object ID column for defining Mongo IDs, and that's what we'll use for the ID field. Once you've defined the entity, you can register it in the app module inside the TypeORM module definition. Then inside your recipe module, you can define a scoped repository module using the TypeORM module for feature method, and make sure you pass the recipe entity as an argument. Then you inject the repository into your service and call the repository methods to interact with the database. And just like in the previous example, we can find the recipes, we can create, update, and delete them. TypeORM provides a powerful set of features for working with your data. You can define relationships between entities, create complex queries, and even use migrations to manage your database schemas. But as with any tool, TypeORM comes with its own set of trade-offs. It has a steeper learning curve compared to other simpler methods like the MongoDB Node.js driver, and especially if you are new to ORMs in general. However, TypeORM can be particularly useful in scenarios where you need database flexibility. For example, let's say you are building an application that needs to support both MongoDB and PostgreSQL. With TypeORM, you can implement the database interaction in a consistent way, regardless of the underlying database technology. Looking at all three methods side by side, each has its strengths. The MongoDB Node.js driver offers simplicity and raw performance. Mongoose provides robust data modeling and validation, and TypeORM brings flexibility and a consistent way of working with many databases types. So if you come from an SQL background, you'll feel at home with that option. But there is nonetheless a major issue. Now that your app connects to MongoDB, how do you test your app without having to connect to a real database? Watch this next video to learn how to write tests for your NestJS app. I'll show you a full testing strategy and how to get around external dependencies like databases and external services.